Section 2.3 Composite functions. A composite function is a function that's composed, put together from two or more other functions. So the two or more functions are combined together to make another function. So over here, in terms of notation, f of g of x means your g is applied first and then applied f. G is the one that is closest to the x, so you can think this is why it's acting first, and then f is acting on g. You could also look at it as f being applied to whatever g of x gives you, so you could surround it with brackets. So if you imagine the diagram, if you've got an input of g, so there's your g input, so the domain of g, x's are going into the next one, the function g is applied first, apologies, so x going in, and you are all going to obtain g of x. So this is the domain of g, this is the range of g. The range of g then becomes the domain of a function f that's being applied. So then the output is going to be f of whatever was inputted, which happened to be g of x. So overall, you can write the function as f g, so f of g. There you go. So the order is really important. It's important to realize, because whatever you write last, that's the first thing that is being applied. And if you think about the notation being written like this, with x, or fg of x, or f of g of x, you could see that g is applied first because it's the closest one to x. So in the example 10, we've got two functions given. F of x is x squared and g of x is x plus 1. We are asked to simply evaluate the following expressions. So what is f of g of 1? So that tells me, let's find what g of 1 is first and then sub it into f. So g of 1 is going to be 1 plus 1, so that's going to be 2. So f of 2 means now I'm going to feed 2 to my f, so it's 2 squared, which is 4. The second example, this one is the reverse order. We are going to put 3 into f, so we're going to find what g of f of 3 is. So f of 3 needs to be evaluated first. So f of 3 is going to be 3 squared, which is 9. So we're going to find what g of 9 is. G of 9 is going to be 9 plus 1, which is 10. And then over here, this is f of minus 2. This could be written as f squared of minus 2, which really means find what f of minus 2 is, get the answer, and then find what f of that answer is. So f of minus 2 is going to be minus 2 squared, which happens to be 4. So we need to find f of 4. F of 4 is 4 squared, so the answer is 16. There you go. So let's have a look at example 11. Here we've got two more functions. F of g is 3x plus 1, g of x is x squared plus 4. We are going to find f of g of x. So this time, rather than evaluating it, we're going to find the overall rule for f of g of x. So that tells me, work out what g of x is, which is x squared plus 4. And then that becomes the input for my function f. So function f at the moment has got over here x's put in, and that tells me to multiply x's by 3 and add 2. So over here I have to change that input into x squared plus 4. So we have to do 3 times x squared plus 4 and then add 2. So just tidying it up to get 3x squared plus 12 plus 2 plus 14. So that is f of g of x is equal to 3x squared plus 14. So it's a quadratic function. So look at this one. So here we've got to feed whatever f of x is into g. F of x is 3x plus 2. So this time we're going to feed, the input is going to be 3x plus 1. Normally it's x here. So, but that tells me the rule. Take x, which is the input, square it and add 4. So we need to take our input, which is 3x plus 2. We're going to square it and add 4. I guess you can expand it. 9x squared plus 12x plus 4 and 4 plus 8. So g of f of x is 9x squared plus 12x plus 8. So that's the answer. Okay, so here we've got to find the rule of f of f2 of x, which is f of x. So that tells me take my function f of x and feed it. So that's my function altogether, and we're going to feed it to another f of x. So f of x is 3x plus 2. That becomes the input into my function of f, which is take 3, multiply the input by 3, and then add 2. So let's expand it. You're going to have 9x plus 6 and plus 2, that's plus 8. So f2 of x equals 9x plus 8. Okay, finally we've got to find b if f of g of b is equal to 62, or f g of b is 62. So the idea is to find out what would I need to feed my f of x function to get 62. So I'm going to solve f of x equals 62, and that will become g of b. So f of x equals 62. I had to pause the video. I realized that I've invented a new function here. F of x is not 3x squared plus 2. F of x is 3x plus 2. So we need to make it equal to 62. Find for what value of x it happens. So that happens for x equals to 20. So now that 20, you see what I found here is that 20 is going to be my input of a function of f in order to get the output of 62. And the input in the question is g of b. So I need to find a solution of g of b equals 20. G of b is b squared plus 4. Make it equal to 20. So b squared is 16, giving me b is equal to plus or minus 4. There you go. So another approach, I mean, sometimes this is the only way of doing it. You need to split it into 2 parts. So first of all, find what f of x, what you need to feed the f to get the answer of 62. So f of x equals 62. Once you get that, you make it equal to g of b. The second way of doing it is by writing the rule for f of g of x. F of g of x is this function here. So we are going to make it equal to 62. So 3x squared plus 14 is equal to 62. So 3x squared is equal to 62, take away 14, so that's 48. X squared is equal to 16, giving x equals to plus or minus 4. So that's the second way of doing this question. Okay, so example 12, you've got 2 functions, f of x, which is written in an alternative way, is modulus of 2x minus 8. So this is f is such that x is mapped to modulus of 2x minus 8. And g of x is x plus 1 over 2. So to find the value of f of g of 3, we can just find the value of g of 3 and then sub it into f. So the value of g of 3, so as you can see that here, there's my function g, and there it is. This is f of, g of 3 will be 3 plus 1 over 2, so it's 4 over 2, which is 2, so it's the same as f of 2, and then we're going to substitute 2 into this modulus function, 2 times 2 minus 8, that will give me modulus of minus 4, which is 4. The second part is solve this equation, f of g of x is equal to x. So let's find the overall function f of g of x first. So remember, that tells me to take the rule for function g, which is x plus 1 over 2, and we are going to feed this into the function of f. So function f is modulus of 2 times whatever it's fed, so x plus 1 over 2 minus 8. So the 2's will cancel, and you've got modulus of x plus 1 minus 8. So it's modulus of x minus 7. Now we're going to replace f of g of x with x minus 7, and we're going to solve this equation when it's equal to x. So there's two approaches. Obviously we'll show it graphically, but the first one, do it algebraically. So solve two equations and then minus that. So with this equation, you could see that you get 0 is equal to minus 7. That's rejected nonsense. Okay, so this one here is minus x plus 7 is equal to x. So 2x is 7, so x is 7 over 2. So that looks like it's our solution. Let's just sketch the graph just to confirm it. Why is it that we've rejected this value? So if you sketch x minus 7, so it's gradient 1 going through 7 on both, normally 7 here, but it will be reflected in the x-axis. So this is y equals modulus of x minus 7. And then we're going to draw y equals x. So that's the reason. You can see the reason is pretty obvious. The y equals x is going to be parallel to the branch on the right hand side, so that's why they will never intersect. So the only solution will be over here, and that's clearly 3.5. So that takes us to exercise 2C. Enjoy.